Hi guys, welcome back. So we just looked at different kinds of waveforms. We looked at stuff like sine wave and triangle wave, and we took a deeper depth into what is pulse width modulation and how we can use it to kind of simulate analog output from a digital device. So I have wired up a simple circuit here. It's basically an Arduino Nano, and there is a LED which is connected to a transistor, and we are going to look at a little bit more into why we are using the transistor, and there is also a resistor to make sure that the current through my LED is limited, because the LED works at roughly around 3 volts. The supply that I have connected from the Nano is at 5 volts, so we need a little bit of current limiting in this. But essentially what's happening is I have ground, which is the blue wire coming from my Arduino. I have the plus 5 volts, which is the red wire coming from my Arduino, and I have yellow, which is my PWM from pin number 9 is what I've selected, but you can choose any of the available PWM pins. Now what's happening here is the signal from the pin number 9 PWM signal goes to what's known as the base of the transistor, and we'll look at that again also a little bit shortly, but it goes to the base of the transistor. The emitter of the transistor goes to ground, and the collector goes to the LED, which then connects to positive through the resistor. So that's how the circuit is designed, and I've sort of mocked it up here that you can see on your screen. The design is fairly straightforward. The black wire is ground, the blue is your signal, and the red is plus 5 volts, and this is how it's sort of hooked up. So there is an NPN transistor, there is one resistor and one LED, just 3 parts over here. So what's happening is, because I am sending a PWM signal over here, you can see that the intensity of the LED is slowly increasing and then decreasing, and it's continued to loop through that. And it's slightly tricky to see that effect on the LED, because light emitting diodes are current operated devices, and right now I'm just controlling the voltage. So there is a very sharp decline quickly, and then it sort of reaches saturation very quickly. But if I just replace this LED, I'm going to pull it out, and I'm going to put a buzzer over here. Like so, and hopefully I'll keep quiet for a while, and you can probably hear the buzzer go and change its intensity. Hear that? So that's how we can use the PWM signal to change or control the voltage that is being applied to a load. Now, one thing to remember is that the Arduino GPIO, or the digital I/O pins, have a limitation to the amount of current that they can supply to a load. You can't connect a large big relay or a big motor directly to this device, because it cannot provide that much current. So how do you operate those devices? That's where your transistor comes in. So the transistor just requires a very small signal on its base, which is our yellow wire or the GPIO pin. And then depending on what type of transistor you use, you can use even large ones which are connected to a big heat sink that can draw a lot of power, and they can power really high power devices like motors or heaters or relays and stuff like that. So once you have a transistor, you can then think of it like a sort of an amplifier, something that requires a small amount of current on its input, and that allows you to control a large load like a relay. So if you have something like a relay, you basically want on and off control. So there's really not much control. But using a transistor, you can also use it as a sort of an amplifier, where you can apply different levels of voltages, or you can control the current flowing through the load by adjusting how the base signal is applied. So in this case, that's exactly what we're doing. We're changing the kind of signal coming into the base, and that helps us to sort of adjust the intensity of the LED or the sound output of the buzzer. So that's kind of a quick look at how to use effectively PWM pins from your Arduino, and also how to couple it with using a transistor so that you can drive higher loads. So think of solenoids, or if you're using motors in a robot, for example, or you want to turn on and off a valve in some kind of a automatic sprinkler system, or any of those applications where you need a device. Think of replacing the LED with something else, and you can just run the whole thing using an appropriate transistor. So that's today's talk about how to use PWM and how to combine it with using a transistor to drive high power loads, and at the same time adjust the voltage or the current that flows through them.